In this video, we will talk about how to convert polar equations to rectangular equations. So there are three formulas that we need to know. The first is r squared is equal to x squared plus y squared. The next is x is equal to r times the cosine of theta. And the last one is y is equal to r times the sine of theta. So with these three formulas in mind, let's work through a few examples. Let's say we're given the equation r is equal to 7. Currently, this is in polar form. But how can we get it into rectangular form, or a rectangular equation that uses x and y? Well, notice that we have r squared is equal to x squared plus y squared. Let's see if we can convert this r into an r squared. So if we were to write r squared, so we square the left-hand side, we can also square the right-hand side. So we can say 7 squared. So if r is equal to 7, r squared is equal to 7 squared. And now that we've written r squared, we can replace this with x squared plus y squared. So this becomes x squared plus y squared. And on this right-hand side, we still have 7 squared. So the only way to simplify this even further is just to do 7 squared, which is 49. So we can write our final answer as x squared plus y squared is equal to 49. And that is how we can convert this polar equation into a rectangular equation that only uses x's and y's as opposed to r and theta. Okay, let's try another one. Let's say we're given r times the cosine of theta is equal to 6. How can we write this polar equation as a rectangular equation? Well, notice that r times the cosine of theta we said is just equal to x. So this whole left-hand side is just x, and the right-hand side is still 6. So actually, this is our final answer. X is equal to 6. That's how we can write this polar equation as a rectangular equation. All right, let's try another one. Let's say we're given the equation r is equal to 2 times the secant of theta. How can we write this polar equation as a rectangular equation? Well, first we need to recognize that the secant of theta is equal to the 1 over the cosine of theta. So if we wanted to, we could rewrite this as r is equal to 2 times 1 over cosine of theta is 2 over the cosine of theta. And now notice that if we multiply this right-hand side by the cosine of theta, we can cancel out these cosine of theta, and we can multiply the left-hand side by the cosine of theta as well. And we'll be left with r times the cosine of theta is just equal to 2. And remember, we said r times the cosine of theta is equal to x. So this whole left-hand side is just equal to x. So our final answer will just be x is equal to 2. That's how we can write this original polar equation as a rectangular equation. All right, let's try one more example. Let's say we're given the equation r is equal to 1 over the sine of theta minus the cosine of theta. How can we write this polar equation as a rectangular equation? Well, we can start by multiplying both sides of the equation by sine of theta minus cosine of theta to get this out of the denominator. So we'll say times the sine of theta minus the cosine of theta. So that these two will cancel out. So on the right-hand side, we'll just be left with 1. And on the left-hand side, we'll have r times the sine of theta minus the cosine of theta. It's equal to 1. So now if we distribute this r into these parentheses, we can have r times the sine of theta minus r times the cosine of theta is equal to 1. So notice that r times the sine of theta, this is just equal to y, this third equation right here. So this can be reduced to y, and this r times the cosine of theta, notice that this is equal to x. So this becomes x. So our final answer just becomes y minus x is equal to 1. That is our final answer. That's how we can write this original polar equation as a rectangular equation instead.